So what is the motivation that I created this new playlist, story generation? Oh, by the way, story generation, the techniques that we use is like dialogue management, conversational AI. So the same kind of techniques could be used, because there we had events, here we have events in order to have a coarser representation of these very sparse sentences. So what is the motivation? The first motivation is that for me personally, I love writers, I love writing, and so it's a different story. And so the next motivation could be this one. The most natural path to natural language understanding and interpretable AI is story generation. And that is what GPT-1, GPT-2, GPT-3, and so on are missing. Their models should be modified. So a good data set, a big data set, is this website, inkit.com, that writers come here and post their chapters, and people or editors find them, and so you can freely upload your text, your book about anything, fiction, anything that you like. And this is a good data set. So we don't need crowdsourcers. Already you have your chatbots can just find these texts, can automatically do web scraping and find all the text. And of course, this is my book, a fiction that will turn into reality. The title of my book is A Proposal for Eliminating the Cycle. And first, I want to introduce two great researchers in this field of story generation. And so story generation is like problem solving. When a writer tries to think about different... First, I should say that we have two ways of generating stories. The first type of writers, they are discoverers. They use discovery. But the second type of writers are outliners. So, of course, we can create a hybrid, which I like, which I use in my stories, hybrid. So in Discover, we don't have an outline. We introduce our characters and then say, for example, one day we get up and we say, oh, I should do that. That is a good idea. But the outliners are like those who have excellent grades and just copy what they tell them, to do, what is good for them. So they have the outliners, they have the outline. They say, okay, first you should do this, then you should do the problem, and then you should solve it. First, you should introduce your characters. And so outliners is very structural. But discovery is more exciting, because suddenly one day you get up and say, oh, you have a new idea, and the direction of your story changes. It's so beautiful. But the hybrid one is more logical, because you want a bit of both worlds. So you combine different ideas. Okay, just let's skip from this. And so I was saying that sentences are very coarse. So we have lots of sentences, but many of these sentences is just one event. It's like hashing. You have lots of data, but use hash tables and use hashing techniques in computer science to say that all of them are just in one bucket, so in one box. And so you simplify it and try to understand the bigger picture. What is the relation between these structures? So in this example, you go from one event to another event. And then given this event, a time t, you go to another event. And then like dialogue. In dialogue management and conversational AI, you go from set of sentences inside one event, for example, starting, to another event, for example, ordering, to how do you order, and then finally you say goodbye, and how do you say goodbye, and those things. So we go from one event to another event, but pay attention, you should get closer to the goal. And this is the idea of reward shaping in reinforcement learning. So you can watch my playlist about reinforcement learning to understand the importance of these rewards. Because not only we are looking to the past, we have an eye on the future. We want to know, are we closer to the goal, or we are just repeating the same ideas in our current event. So we go from, it's a plot. You have different points, you're structuring your beautiful story, and so finally this is your goal, marriage, for example. And so the story graph, I really like this article. It's very natural because you go to branching story graphs. It's more general, and so we can see narratives as logical proofs. As you can see in Professor Riddle, I use his slide here, and so we have an initial state. We go to different states. For example, red greets wolf, and so we find a sequence of actions that proves the goal state is reachable from an initial state. Actions have logical constraints, preconditions, postconditions, and so we can see narratives as logical proofs. So finally you reach the goal, which is the end event, which is your final solution to the problem. As I said, every story should have a problem, so that you should discover the answer. How can you find a solution to that? How can you get closer to that answer? And so event representation is very easy. You just first you pre-process your corpus. As I said, you can use lots of data sets. And so when you pre-process that, you can say that, for example, use semantic parsing, subject, verb, and object. The kind of parsing, it depends on you. For example, you can use word class, verb class to represent, because a sentence, you can simplify it in this structure so that you understand the event. Because many of the sentences, these dots are sentences, are inside one event. This is just one event. And you go from one event to another event that contains lots of sentences. So how do you create this? As I said, use either word class, verb class. This is the simple thing, or even other techniques. So another good researcher is Clara Martin, and so we eventify, as I said, we go from event n to event n+1, but we should come back to the sentence, because the basic building blocks of a story are sentences. So you should come back to the sentences. And from this sentence, you can use another models to create a sentence at next state, and then you feed it again. So it's a loop. Again, this is the next sentence, and then you eventify it, and then so this loop continues until you reach your final goal of your story. So the lower perplexity is better. As you know, perplexity is a beautiful concept and measure in language models in NLP. And so you should know that lower perplexity is better because it has less confusion, less guessing. You know, in beam search, in decoder, when you want to decode something, you use beam search, and depending on your model, you could have different unrelated sentences, prediction of some generation of sentences that are not even related to what you want to talk. what that chatbot was intended to do. So in order to reduce it, we should have a lower perplexity. It means higher coherence, less guessing, less confusion. And the story generation problem, at each step, we should get closer to the goal, as I said. We can use different models, sequence to sequence models, and so on. So we go from this, we have different rewards from going from this node to the other nodes because we need these rewards to shape the reward in order to say that are we getting closer to the goal, which is this final goal, or not. So this is a really beautiful article that I highly suggest. Controllable neural story generation via reinforcement learning. And so at each step, we should get closer to the goal. We use rewards in reinforcement learning. And a good way to create these distances is this. Because in a reward, if you know the distance, then you should know you can shape the reward to get closer. So the distance component of the reward function measures how close a verb V is the target verb. So the purpose is to reward the network when it produces events with verbs that are closer to the target verb. So S is just a subset of stories in the corpus that contain V prior to the goal. And this one is the length of the story. And so the distance is the number of events between the event containing V and the events containing G in the story. So subtracting the length of a story gives a larger rewards when events with V and G are getting closer. So this is a beautiful article, Event Representation for Automated Story Generation with Deep Neural Nets. And so, as I said, we have sentence, we eventify it, you go from one event to another, but we should come back to the sentence space instead of event space. And finally, you have the next sentence. And then you give this new sentence to that, and then this repeats, this loop repeats. So it's very much like dialogue management. So story generation is so whatever model you use for dialogue management, you can just use it for story generation and write your archive paper. And so there are some basic building blocks in my mind. So these parsing methods, for example, these syntactic parsing methods, these semantic type parsing methods are building blocks for more complex problems, more complex NLP tasks, such as machine translation, abstract summarization, question answering, and also computational argumentation, computational creativity, computational etc. And whatever you need to know, first attention. It looks into the past and the future, especially modern types of models like transformer architecture. Of course, it's very, as I said, the computational complexity of transformer model is huge. That's why we go to the old school of using attention-based LSTM models and attention-based GRU models and so on. And event generation is really important because, as I said, our sentences are very coarse. So you want to hash them into some building blocks because you can manage these building blocks easier. Just like a writer can structure the story. For example, 500 pages of a story, a fiction, a novel, and so he has some building blocks. If he's outliner, he has some outlines. So, for example, in chapter 1, I say the first part of the story and then you move to the next part. It's like dialogue management. For example, the dialogue management chatbot of Google, they go from one event to the other in order to talk to this customer, so in that sense, story generation is almost like dialogue management. So I have a playlist for conversational AI, for dialogue management. I have a playlist for story generation. And if you look in future, you will see the techniques are quite similar. The problem are different, but the techniques are important. They are quite similar, because what is important is attention. The other important things is reward shaping. That's why reinforcement learning and those ideas come and help us in order to get closer to the goal, which is the final event of your story or your dialogue.